Okay, we're going to look at the second page of CAPM graph stacks. So this time we're starting with velocity graphs and having to draw position and acceleration graphs. The acceleration is the easier part to do, so we'll do that first. So in the first one, our velocity has a slope of 0, so we have an acceleration of 0. This is just CVPM. The second one, the velocity slope is positive and constant, so our acceleration is positive and constant. That's CAPM. In C, our velocity slope is negative and constant, so our acceleration is negative and constant. In this one, the velocity value is positive, but the slope is negative and constant, so it is a negative acceleration. All that matters there is the slope. We have two stitched together here in E and F. In the first section of E, our velocity slope is positive and constant, so we have a positive acceleration. Here we have a flat v-graph, so a slope of 0, so an acceleration of 0. In F, we start out with a slope of 0. It's a negative value, but it's a 0 slope, so that tells me the acceleration is 0. And then we have a positive slope on the v-graph, so a positive acceleration. Okay, even though it's a negative value, it's a positive slope, and the positive slope is what is important. Okay, in G, our velocity graph starts positive and ends negative, but the slope is constant and negative, so is our acceleration. And in H, the slope here is constant and positive, so is the acceleration. Okay, now for the CVPM bits, it's not too bad to draw these lines. For A, we have a constant positive velocity, so I should have a constant positive slope on my position graph. Okay, I could start that anywhere, by the way. I could start any of these position graphs anywhere. If that's not given, then it's just arbitrary and it's up to you. So that's a CVPM graph. In B, what I'm looking to do is draw a graph whose slope starts flat, because it's a 0 value here, so we should have a 0 slope, and then gets more and more positive. So I'm going to start here, just arbitrarily, with a flat graph that gets more and more positive. In C, I'm also starting with a flat graph, but then the slope is going to get more and more negative. So I'm going to start up high just so I have room to draw. Start flat and get negative. In D, my slope ends flat. My position graph should be flat at the end, but it begins with a big positive slope. So I'll just start here arbitrarily with a big positive slope that gets smaller and smaller until it goes to 0. In E, I have a graph similar to B at the beginning, where I start with a flat slope, with a slope of 0, and then get more and more positive. And then that positive slope that I had at the end of that graph continues. So I'm going to have a linear graph section after that, at that slope. In F, I start with a big negative slope that's constant for a while. So going like that. And then that slope gets smaller and smaller values approaching 0. So it flattens out at the end. In G, I start with a big positive slope, but in the middle, I should have a flat place, and then a big negative slope at the other end. So I start positive and get flatter and flatter until right there I have a flat spot, and then I get more and more negative. In H, I kind of do the opposite. I start with a big negative slope, and then I flatten out to 0, and then increase away.